All right, so in this video, what we're going to do is just, again, more geometric proofs. We're going to explore and write a conjecture and proof off of this piece, right? So Carly just proved that the base of the triangles are congruent, right, in the previous isosceles problem. She wonders if the same things will be true for a trapezoid, right? So we want to kind of figure out what's going to happen. Okay, so here's our first question we want to explore, right? So if angle H is congruent to angle G, how do the non-parallel sides, these two sides, appear to be related, right? So if we kind of think about an isosceles triangle, right? If we have an isosceles triangle, ooh, that's a horrible isosceles triangle. Let's draw that one again. Okay, so here, let's pretend that this is an isosceles triangle, and if our base angles were the same, we just proved that these would be the same. So it seems that we should say something to the effect of maybe each EH would be congruent to FG. That seems to be kind of the alley of line segments. Okay, so let's write a statement based on that information, right? So if a trapezoid has congruent base angles, then it is isosceles. So there's our conjecture, right? It seems kind of based off of an isosceles triangle. It seems like this should totally work. Okay, so let's go ahead and try to prove that this is true, because it is true. So how can we use the theorem about an isosceles triangle to help prove your conjecture about trapezoids? Right? So to help you get started, extend the non-parallel sides of the trapezoid to form that lovely triangle. So what do you know about the triangle IHG, and what about IEF? Okay, so again, try pausing the video and coming back to it. Okay, so let's see what we know. Let's write some statements out. So statements and reasons. All right, so let's start off with the most logical one. So you should have started off with that E, F, G, and H is a trapezoid. Right, that's the first one because we gave it to you, right? It was given information. What do we know about a trapezoid? Well, it was also given to us that things are parallel to each other. So here's first statement. So second statement, we would say that EF is parallel to HG, right? And again, I'm going to say definition of a trapezoid for that one. Okay. What else could I say based off of that piece of information? Well, if this information, I now know that if I kind of extended it, the measurement of JEF would be the same measurement as H. So maybe I can say something to that effect since I've kind of made it large up there. So I'm going to say that angle JEF would be congruent to angle H. And I'm going to say because the lines are parallel, so we have corresponding, so these are corresponding angles. That being said, I can also say JFE and angle G. So I'm going to say, angle JFE is congruent to angle G. So again, they're corresponding angles. What else do I know? I should probably put that other piece of information down here. So my fifth piece of information is that angle H is congruent to angle G, and that was a piece of given information. Let's see. So if angle H, right, and angle G are equal to each other, that means that JEF and JFE, these angles, are now officially equal to each other. So I'm going to say this. I'm going to say angle JFE and angle JEF are congruent to each other. And why did I do that? I did it by substitution. So substitution, right? Nothing fancy. fancy schmancy, okay? But what do I know? That JE and JF, they should be equal to each other because of the definition of an isosceles triangle. So I'm going to come up with number 7. So JE would be equal to JF, and I'm going to say definition of isosceles triangle. And if that is the case, what else do I know? I know, let's bring it down a little bit more, that, oops, can't see this anymore, that JH, right? Let's think about this logically. So let's say JH is made up of JE plus EH. I also know that JG is made up of JF plus FG, right? Why do I get to say that? Reason based on the diagram. So segment from picture, right? So sometimes it's not an actual like reason definition. What do I know? I know that JH and JG is a larger triangle. So I'm going to say that JH is congruent to JG, and it's the same reason up here. So definition of isosceles triangle. And if that is the case, that means that we could kind of use a little bit of substitution. Okay, so if I know that these are equal to each other, so if I use all of this information, right? So let's bring it out over here. So first I know that JH is equal to JG. So based on this, I can now say JE plus EH is equal to JF plus FG, right? So that's exciting. I also know this, JE and JF are equal to each other, so I'm going to replace my JF with a JE now, plus FG, which means that those two will cancel out, leaving you with just this piece of information. So, last thing, I'm going to say that EH would be equal or congruent, I should say, FG, right? And what did I do? I just used substitution. I used math. Okay? And if these are congruent to each other, that means ultimately that we approved what we wanted to, that this would be an isosceles trapezoid. So therefore, number 11, dun, 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 EFGH is an isosceles trapezoid. Very exciting. Why do we get to say that? Definition of an isosceles trapezoid. So again, just another problem. We can put this theorem into our graphic organizer, so now we don't have to worry about proving it ever again.